Hello everyone. Hope everybody is there. Yes. So how are you all dear? Yes. How about your studies? Start. पता है बच्चा party? Just ask your friends to join it. That share to your friends so that more can join us. Welcome to Unacademy. This is Sharada Alok. I've been teaching chemistry at one of the renowned coaching institute of Kota from past 10 years. Yes, please guys join fast. Welcome you all for our latest NEET UG English channel. And this is the second class of chemistry of it night batch. So guys, what is the benefit of taking this subscription of Unacademy? What actually Unacademy does for you? See, by taking the subscription, you are accessible to a daily live classes where you can get interacted with the educator live, where you can ask your all your doubts there itself and get it cleared that there itself, so that your topics can be prepared properly, right? And those, whether like what about your preparation level, in order to see the preparation level what is done. So what is done, we run live tests and quizzes as well. In order to run all these live tests and quizzes, what is the benefit of that? First of all, you must be wondering like what is the benefit of having all these live tests and quizzes? See, you, the moment you give the test, the moment you get score in your hand, see, it gives confidence to your level, it gives an exact analysis about your preparation level. It emphasizes you to go deep into yourself, think over that, think for the particular topic, and just it enhances your self to improve a bit in that particular topic, so that gradually your scores get better and better. Yes, what about what we are doing as educator here? We are going to give you a very precise structured course which is actually designed by top educators across the nation. And by having all those scores, it ensures that suppose you all are preparing for NEET UG, so you won't be getting anything extra than what is being asked, what has been asked so far in NEET UG, right? So you don't get, scattered here and there. Everything is in a precise way, everything is in a constructed way, so that you need not to wonder either for the notes or for the concepts or for the doubt clearance, right, guys? Then we have here you have to take the subscription, and just by taking one subscription you are accessible to like either the live classes you talk about, or the live test you talk about, or the quizzes you talk about. You get access to all of them. And even if you are a student proper, for suppose you can get access to class 11 live test classes, live classes, quizzes, and your doubt clearance as well, along with class 12 syllabus, right? If you're a class 12 student, suppose some of the topic of class 11 is not cleared, it is very easy for you to get access to that as well, guys. Okay, let me see who all, anybody has joined or not. Yes, guys, please share it to your friends so that they too can join us. Okay, guys? Yeah. So, guys, how to get the subscription? Let's come to that. First of all, you have to, download the educator learning app from the Play Store. Then you will be have to click for NEET UG. Then you'll be having all these options coming in front of you. You can see the options are right from 1 month to year, guys, as per the requirement of the student. I would suggest, like, if you are a student of dropper or a student of class 12, you must go for 2 years subscription instead of going either for 1 month, 3 months, or 6 months in order to have complete benefit, because you have to pay only for the 11 months. How come? Let me explain you. Like, for if you take subscription for 1 month, you are supposed to pay 5,400 only. If you are taking for 3 months, it comes out to be 13,500. If you are taking for, say, going for 6 months, you are supposed to pay 21,600. And suppose if you go for 1 year, you're supposed to pay 27,000. And in case if you have paid 1 year, if you have taken subscription for 1 year, and at the end of the year, if you decide to continue for 2 years, what you'll have to do, you'll have to pay for this 1 year again. So in that case, you will be thinking that, in fact, you will be regretting that you would have taken the subscription for 2 years long back. That would have been much better for you, right? So for if you are a student of class 12 or a student of, what you should what you should do, you should take subscription for 2 years. And if you're a student for like if you're a student of class 11, you must go for the subscription for 2 years. And if you're a student of class 12, you should take subscription for 1 year, and in that only you'll be taking access to like 2 years course. You can get access of class 11, you can get access of class 12 as well. If you're a student of dropper, you should take again the subscription for 1 year by paying 27,000 only, but you will be able to get access of class 11 syllabus as well. But all you are going to get by applying this referral code SA10 of mine. Don't forget to apply my referral code SA10, guys. Then only you will be able to have all these prices. Now, coming to the Haloalkane part 2. So this is the lecture 2 of Haloalkane, guys. What are haloalkanes? We have already discussed in our previous lectures, guys. Now, what you have to do here, see, we have discussed halogenation, okay, of alkane in order to prepare haloalkane. So in this video, what we are going to see, we are going to beyond that, okay. So you have seen that how to prepare haloalkane by halogenation of alkane. Now, what we are going to see today is, if what will happen if excess of chlorine is added here, right? Excess of chlorine. Let me see who all have joined. Guys, if you have any doubt, you can ask. You can message in the drop box. Okay. Now, see, here you can see that this methane is being added to chlorine gas, and this H nu, this H nu represents photon particle, that is light. This is light, guys. So what will happen in presence of this? It is going to undergo free radical mechanism, which we have discussed in our previous video. See, what will happen if excess of halogen is there? Gradually, this chlorine atom is going to substitute all the hydrogen present in case of methane. Here, one chlorine has substituted one hydrogen, and we are getting CS3. In this case, one more hydrogen is substituted by chlorine, and we are getting CH2Cl2. One more hydrogen is replaced by again, and we are getting CHCl3. And finally, all the chlorine atom has been added to this. You can see that all the hydrogen of methane is substituted by chlorine, and it is forming what? PCl4. So you can see that we are getting, all these products, like this is monochloromethane, then this is dichloromethane, this is trichloromethane, and this one is tetrachloromethane. Okay, now this mono, di, tri, tetra, we are going to see them in the next slide. What you have to see here, if excess of chlorine is there, it is gradually going to substitute all the hydrogen of methane. Suppose if excess of chlorine is not there, what will happen if it is not there? We'll be getting only some product, like suppose very less amount of chlorine is there, we'll be getting either this or this, right? If excess of chlorine, you are going to have all these variety of chlorine, guys. I mean chloro halo products. So here you can see that halogen, all these, what do we call all of them? Call all of them as halogen derivative of alkane. Derivative, what is the meaning of this derivative, guys? Derivative means what? Derivative means something which is derived from. See, this one is alkane, and by undergoing halogenation, we get haloalkanes, a variety of haloalkanes like this one by one. So they all are derived by substitute or by replacing hydrogen. They all are derived by replacing hydrogen from where? From this particular alkane. Right, guys? Now, that is the reason we call them as halogen derivative. What do we call them, guys? We call them as halogen derivative of alkane. Okay, if you are watching the video, please don't forget to like, don't forget to share your friends in order to like them as will have the benefit of this particular lecture, guys. And please, if you are new to the channel, don't forget to subscribe it. Now, Now let us see how to name all these haloalkanes. Okay, first of all, remember the name is based on different varieties. Like first of all, we have to see, we have to name them on the basis of these halogen atoms. That is, how many halogen atoms are present in the particular haloalkane. On that basis, we are going to name them. First of all, if the compound is having, if the haloalkene is having only one halogen atom, guys, we will be calling that as monohalide. Very simple, mono. Mono stands for one. That is, the compound is having only one halogen atom, then we will be calling it as monohalide, guys. Okay. Now, suppose if the compound is having dihalide, that is, the compound is having two halogen. In that case, it will be called as di, which it is very clear from the term di, isn't it? Di matlab kya? Do, not that di, guys. So dihalide, di matlab do. Okay, if the compound is having two halides, it will be called as dihalide. Now remember, if more than one halogen atoms are there, that means it is having an option. We added either to one carbon atom or two carbon atom, and those two carbon atom can be adjacent, they can be far. Now on that basis also they are further divided, they are further named as geminal, then vicinal and terminal as well, which we are going to see in our next slide. First of all, let us concentrate on geminal. See, this geminal will have both the halogen atom. Can you see this X represents the halogen atom? This X for fluorine, chlorine, bromine, iodine, guys. Okay, see if the halogen atoms are attached to one single carbon atom. Can you see here? They're attached to the single carbon atom. In that case, we call it as geminal. Okay. And suppose if the halogen atoms are attached to the carbon, which are, adjacent. These are adjacent. Adjacent means the one next to the other. So here you can see that both the halogen atoms are attached to these two carbon atoms which are consecutive, that is adjacent. In that case, we'll be calling them as vicinal. I'm repeating, we'll call it vicinal. Okay. Now, how to recall this? There must be a punch click requiring over here because it seemed to be confusing at the time of solving the paper, right? So geminal. How will you recall this geminal terms? This geminal has come from the term germination. Can you see a picture this side, guys? Can you see a picture? Germination. So let the seed be the carbon atom. Okay. The seed be the carbon atom. Now you can see, as you all are a bio student, that is the reason I have taken this example. So you can see that this is the shoot part, right, guys? Biology students, all the students here, medical students. I'm not asking, I'm not talking anything, extra, not Greek. I hope you all are getting this. Suppose this is the seed, which is the carbon atom. Now, this shoot and this one is the root part. Both of them are attached to the carbon, and we call this, what do we call this process? Please, what do we call this process? Write in the comment box. No reply yet. Fast, guys. Very good. Yes, it is called as germination. What do we call this? Germination. So from germination, we got the term geminal. So here, shoot and root, you can see both of them are added to the seed. Similarly, both the halogen are added to the carbon, right? Therefore, from germination, we have taken the term as geminal. So this is going to, work as a punch click. So geminal, repeat, geminal means germination. Okay, वहां से you have to relate it that germination as shoot and root both are attached to the same carbon atom. Similarly, both the halogen atoms are attached to this single carbon atom. So it is geminal. Now look at this vicinal. Vicinal. Ignite batch students. Please, all of you join us without delay. You are being taught here by the very basic. No matter you have not studied, either GOC or anything like basic organic chemistry, any general organic chemistry. If you have not studied in class 11, there's nothing to worry, guys. I'm here to tell you all those to cover all the basics, okay? So, no doubt we are going to study the very first organic chapter, Haloalkane and Haloarene of class 12, organic chemistry. But you need not to worry. You need not to worry for the mechanism. You have not GOC. You have not studied in class so far. General chemistry, if you have not studied general organic chemistry in class 11, you need not worry, guys. But here you have to, pay full attention. Take all your copy and pen, guys. Yes. And keep noting down the things. I'm going to cover right from the basics so that you won't feel anything left out or anything missed out, or you might not like have studied anything that, that low feeling will not be there. But before doing that, you have to take a copy and a pen with you so that you keep noting down everything. Okay, guys. So geminal, I hope it is clear. Now come to vicinal. See, as you can see that both the halogen atoms, they are attached to the adjacent carbon atom. So how to recall this? If you, stretch it a bit more this way and here as well, which letter it looks like, it gives an impression of V to you, isn't it? V wala letter, it looks like V. Yahan se you have to arrange it, okay? And you have to draw in this way so that it looks like V. So V stands for vicinal. Or you can either remember it the way like V for vicinal, like all these are these are two ends of the V part. To that we are adding halogen. Okay, vicinal. Okay, guys. So I hope you're not going to forget it ever. Geminal for both the halogen are added to the same carbon atom, and for vicinal they are attached to adjacent carbon atom, guys. Now, if the compound is having more than two, that can be the three or more halogen, we'll be calling them as polyhalite, right, guys? Polyhalite. And remember, if it is di or tri or tetra, whatever, it may be possible that same halogen may be there or different halogens may be there. Okay, guys. Now, the most famous polyhalides are trihalides that collectively called as halo form. You must have heard this name long back. Halo form. This halo will stands for either fluoro, chloro, bromo, or iodo. Now, these three famous haloforms are there. These are the three famous ones. CHCl3, you can see that this is actually what? Yes, it is chloroform, which is used as anesthetic. All those bio students must be knowing why dissection, in order to, anesthetize the particular dissecting object, what do? You treat that, whatever the specimen is, you treat that with chloroform. It's used as anesthetic, right? So chloroform, this is chloroform, this is bromoform, and this one is iodoform. Yes, guys, this is very important as long as organic chemistry POC is concerned. What is POC? POC is practical organic chemistry. You get this is what? This is iodoform. You get yellow color precipitate for iodoform if the compound is having what? Either methyl carbinol or methyl ketone group in that case it is going to give it alkaline iodine, it will be giving iodoform, the yellow precipitate of iodoform, and only the compound having methyl carbinol and methyl ketone will give positive test for this. So these two are very, very important. This is chloroform, this is iodoform. So most of you are must be wondering, ma'am, as like today she is in a mood to teach biology. No, not like that. But yes, as you all are medical student, it's my it's my pleasure. It my, like to give you some to relate it with some biological facts as well, because I think that you all are very good in biology. So it will help you there. थोड़ा सा मजा आता है ना, like okay guys. So I hope it is clear. Now, can you see something over here? In the previous slide, you had seen that if all the hydrogen is replaced by chlorine, it forms CCl4. Yes, it is carbon tetrachloride, guys. You know what is the use of carbon tetrachloride? It is used as pyrene. You know what is pyrene? This carbon tetrachloride is used as one of the fire extinguisher, guys. But where, yes, yes, it is used to extinguish the fire which is caused in electrical appliances, because you cannot extinguish there the fire with water. You know what will happen? Yes, bujhane wala hi bujh jayega. If you're going to extinguish the fire of electrical appliances by water, you won't able to extinguish the fire. Rather, you'll end up to extinguish yourself. Okay, guys. So there, to extinguish the fire, instead of water, we are not supposed to use water there, guys. Remember, because bujhane wala hi bujh jayega. Yes. So there we are supposed to use this carbon tetrachloride, and which is now marketed under the name pyrene. Now, can you see this compound CF3, CF2, CF3? This is octafluoropropane, very famous compound once again, guys. So all these are like few examples coming under polyhalides, guys. And remember, this halogen atoms can be same, they can be different, guys. Okay. Now, on the basis of that, like let us discuss this dihalide, that is gem dihalide in detail, guys. Gem dihalide. But before that, if you have not shared it to your friends, please ask them to share it so that they also can get full benefit out of the video right now. And if they have any ask, doubt, they can ask me right here. Hey guys, and if you're new to the channel, don't forget to subscribe. So guys, you all are watching the Ignite batch. Okay, they are like either you are a student of class 11 or 12 or dropper. You're going to get everything, every single, every single basic things of organic chemistry, physical chemistry, or inorganic chemistry here. So as you are being taught hello alkane here, I'm trying to cover each and every basic things which you might not have studied in 11 if you're a student of class 12 or dropper. And for 11 to balle balle hai hi hai, they are going to get like everything in very basic things. Okay, so let us see gem dihalide, guys. We had already seen that the halogen atoms are attached to same carbon atom. In that case, we are going to call them as gem dihalides. Now, how to name them? See, this is the common name, because IUPAC name is not a problem at all, because one that is a position of what? They are simply one dihalide. As long as you are talking about common name, so in that case, what we do, we name them as alkylidine. You know what this alkylidine stands for? This alkylidine is, suppose this this particular group is called as alkylidine. Okay. Now here it is, suppose it's single carbon methylidine, then ethylidine, two carbon propylidine, the same way. Okay, let us see them one by one. Here you can see one example. This is two carbon atoms, CH3CH. Now to this, two halogens are added and two carbon atoms are there. So this will be named as, yes, think over that. How to name it? Right, ethylidine. Okay. Now here one more carbon is added like this. So this one is propylidine. Now come to cycloalkane. Now here, suppose this two hydrogen of cyclobutane are replaced by two chlorine atom. How to name this? Very simple. This lidine is going to be common. Okay. Instead of this alkyl, you have to add cyclo alkyl, right? So this will be cyclopropylidine, guys. What? Cyclopropylidine. Now this one is very simple. Yes, anybody? Okay. So this is cyclopentylidene, right? Similarly, you can go for cyclohexadiene and on, right? See, here the names are there. Ethylene chloride, propylene chloride, cyclobutylene chloride, and cyclopentylidene. Right here. Now let us see dihalides in that case where the halogen atoms are attached to adjacent carbon atom, guys. Can you see? Here, vicinal, we call them as vicinal dihalide. What do we call them, guys? Vicinal dihalide. Now here you can see that instead of, the halogen, instead of getting attached to the adjacent carbon atom, they are attached to alternate. They may be either 1,3 position, they may be 1,4 position. Okay, that is far, not on adjacent. So what we are going to see for them? See, they are called as terminal dihalides, right? Terminal. Halogen added to far carbon atoms are called as terminal. But those far carbon atoms, they should be attached to the carbon chain like this. Okay. Now, here, how it is to be named? Simple. Ethylene chloride, dimethylene chloride. They will be named as ethylene chloride. Remember, guys, I hope you know the difference of ethylidene and ethylene. So here, this ethylene term, how it came. See, what you have to see that how many CH2 group are there in that particular chain. Here you can see it is one CH2 group. This is another one. There are two CH2 group. Okay. So therefore it is also called as dimethylene because CH2 is called as methylene. So dimethylene, you can either call it as dimethylene chloride or ethylene chloride, guys. Now look at this particular one. This is terminal dihaloalkane, how to name them. You can see you have to simply go on counting the CH2 group. How many CH2 groups are there in total, guys? Tell me. Yes, there are total three. Three methylene group. Therefore, it is named as trimethylene chloride. The CH2, you can see the bonds where the carbon is further supposed to be attached to the four groups. So the CH2 is called as methylene. So the compound on the basis of methylene group it will be named as, if it has four, it will be tetramethylene, pentamethylene, and so on. So how to name them? IUPAC basis. If they are on the adjacent position, sorry, on the same position, we'll call them as 1,1. If they are on the adjacent position, we'll call them as 1,2. That is vicinal. On the same position, it is geminal. And if they are on either 1,3, 1,4, or 1,5 on, they'll be called as terminal position. I hope it is very clear to all of you guys. If you have not shared so far to your friends, you are kindly requested to share them so that they also can benefit out of the video, guys. And if you are new to the channel, don't forget to subscribe it. Okay, now we are doing the very basic of haloalkane, guys. Okay, so don't forget to take your copy and pen with you. Don't forget to jot down the things. How to differentiate between geminal and vicinal dihalide, guys. This question has been asked many a times in NEET. Okay, so how to differentiate, guys? It's very important point. All of you take your pen and copy with you. Geminal and vicinal products. Many times it is asked, guys. So please be full attention over here. Just pay full attention over here, guys. Okay. So how to differentiate between geminal and vicinal dihalide we're going to do, guys, here. So if it is geminal dihalide, you know how the way it is going to react to aqueous NaOH or acidic water, how it is going to react. It is going to react the very same way. In both the case, what will happen? All these two halogen atom will be replaced by an oxygen atom. Yes, what it is going to form in that case? Very good. It will be forming carbonyl compound. You can see the carbonyl compound. Now tell you, just tell me where you find this group. You find this either in ketone. Very good. You find them in ketone or in aldehyde. That's great, guys. Carbonyl compound, this aldehyde and ketone, they together consist of what? Carbonyl compound. So what will happen if geminal halide is there? After adding aqueous NaOH or acidic water, both of them will react the same way and convert the very geminal halide into the respective carbonyl compound. Okay, guys? Now, you can check whether the carbonyl compound is being formed or not. Can you suggest me a particular test for that? Yes, I've given the hint. What does D and P it stand for, guys? Anybody in the comment box, please write down. Okay, this 2,4-DNP it stands for, this D stands for dinitrophenyl hydrazine. Okay, so what it does, guys, this 2,4-DNPH reagent is very famous and the only test to for carbonyl compound, to test the presence of carbonyl compound. If suppose this is geminal dialide, after adding these reagents, any one of these reagents, you'll be getting carbonyl compound, and if it is carbonyl compound, it is going to give an orange color precipitate with this 2,4-dinitrophenyl hydrazine. Okay, guys. So if it is a geminal dihalide, after adding these reagents in sequence, like one by one, if you are getting orange color precipitate, that means it is geminal dihalide. And if you are not getting orange colors precipitate, that means the reaction will of course be there even if it is a dihalide, but you won't be getting all these like carbonyl compound over here. And if there's no carbonyl compound, there is no orange color precipitate with 2,4-D H reagent. Is this clear, guys? So this is actually the very easy, like, trick for geminal and vicinal dihalide. So don't forget this one, to differentiate between them. And remember, guys, it has been asked in many times, like in NEET exam. So can you, guess the product over here? This particular question was asked two times in NEET exam, guys. Okay, identify the product here. It's very simple. First of all, in order to identify the product, you have to identify the type of halide here. Can you guess the type of halide? This one? Yes, both the chlorine atom, as both the chlorine atom are attached to same carbon atom. So it is what? It is geminal dihalide. And you know what geminal dihalide does with, like, aqueous NaOH? How does it behaves with aqueous NaOH, guys? Mark lagaiye, just you supply your brain just now. Yeah, Jan. Yes, that's great. So what it does, it is going to this NaOH, aqueous NaOH is going to replace both the halogen by oxygen atom. Very good, guys. So this you are going to get. Both the halogen will be replaced by one oxygen. And what type of group forming here? Yes, this is what? Carbonyl. Tonic group is there. Can you see here, guys? So this is the product. Remember, guys, this has been asked in like two times in NEET exam. So be very attentive. Don't forget to jot down. Now, guys, going ahead, naming on the basis of hybridization of carbon atom. You know what hybridization we are talking about here? See, as we are doing naming of haloalkanes, so we are talking about the hybridization of carbon which is attached to halogen atoms only. See, till now we have seen that this halogen, this is added to sp3 carbon atom. Now what will happen? How it is named? If it is attached to a carbon which is having sp2 hybridization, guys, yes, it is going to name differently as vinyl halide. Can you see? This carbon is having two single bond and one double bond. In that case, its hybridization is what? sp2. Remember, if all the bonds of carbon are single bond, it is sp3 hybridization. Okay, guys? And if two single and one double bond, it is sp2. And if one single and one triple bond, in that case, the hybridization will be sp, right? So here you can see that this halogen is added to sp2 carbon atom. Therefore, it is vinyl halide. It is called as vinyl halide. Remember, guys, the example of vinyl halide, this is a very popular compound. It is very useful as well. So it is CH2CHCl. This is vinyl group CH2CH, where both this carbon are sp2 hybridized, and this halogen is attached to this sp2 hybridized carbon. So it is vinyl halide. Okay, guys, can you see this? Now, it is like it has got a very important industrial use. And what is that? That is preparation of polyvinyl chloride. See guys, here we are not only doing haloalkane. In fact, this particular thing can be asked in polymer chapter as well. This particular can be asked in the common name of this particular compound, that is in under IUPAC name as well. So you're not doing only one topic here. You are actually targeting three topics altogether. You might not know where the question can come from. Okay, so be very attentive. Some of you might be thinking that okay, we are all done with hello alkene, we need not to watch the video. I am going to tell you that you really need to do the video, because it is actually not only hello alkene, it will help you. Like as a tree is having different branches, the same way it is also having different branches. Like the same thing can be related to different topic as well. So it is always better to have this video. Okay, it is going to help you not only for this hello alkene, but it will be helping you for some polymer as well, or some polyhalogen compounds as well. Like in chemistry in everyday life as well, this PVC can be coming, and we'll be seeing this hello form and everything. They are being, you're going to study them again where in chemistry in everyday life. And here if you have not passed your time there, you are going to enjoy it. Okay guys, तो पहले मजा बाद में सजा नहीं करना है, पहले सजा बाद में मजा. सजा मतलब पढ़ाई ही है for you. Like for some of you, I'm sorry, there are many like are very good student of Ignite batch, like Ignace, like a lot of energy is there in them, most of the student. Okay guys, so it is clear. Vinyl halide, see this N stands for number. So many number of vinyl chloride together polymerize into polyvinyl halide. What is the use of this polyvinyl chloride? PVC. Must have heard the sanitary pipes and all PVC pipes. Yes, they are this only. You can see how it is, how this polymerization. No doubt it is how it is taking place. See, you can see that there is a double bond here, which is very famous to undergo addition reactions. What happens out of the two? One bond gets broken down, and if one bond gets broken down, both the carbon atoms becomes free to attach to another group. So what happens? This carbon is attached to one vinyl halide, and this gets attached to another. Similarly, that process goes on, and finally we get a giant product, that is PVC, which is represented this way. See, you have taken n molecules of vinyl halide, and all those are added by single bond, and therefore we are just representing a single unit this way, where this n can be many, and this together is called as a polymer, which is polyvinyl chloride, abbreviated as PVC. And you must have heard in your daily, like in your home as well, that PVC pipes hai kya, like in advertisement also, if you have seen the sanitary pipes advertisement, you must have observed they talk about PVC pipes guys. So that PVC stands for polyvinyl chloride. Okay, now, guys, vinyl halide do not undergo substitution reaction. The most important part, the very important part of alkane is this. So gradually we are going into much more important things. Okay, so this is the very beginning, and in fact very basic as well. So don't worry. So, okay, guys, I'm going to cover it right from the basic. Don't worry for that. Vinyl halide do not undergo substitution reaction. Why? You can see this is the structure of vinyl halide guys. CH2 double bond C. This is X. Can you see all three lone pairs on this halogen? And these lone pairs are in alternate position with what? Yes, double bond. So it is a situation of what? What type of conjugation can be possible here? Conjugation that is alternate position. They are having double bond and lone pair. So what will happen? There must be a conjugation. What type of conjugation? Pi bond and lone pair conjugation. Okay guys? And that is actually the main culprit that vinyl halide do not undergo substitution reaction. Let us see that in detail in the next slide. But before that, this what is substitution? Whenever we talk about this substitution, guys, whenever you talk about this substitution, what type of substitution we are talking about? We are talking about nucleophilic substitution, which is abbreviated as SN, where this N stands for nucleophile and this S stands for substitution. Okay, but before going detail into nucleophilic substitution, let me tell you what these nucleophiles are. Remember, guys, I'm doing all this for you because all class 12 or drop a student, I think you might not be studied this. And class 11 nucleophiles, you must have studied it, but I'm going to repeat it again. Please look much with much concentration, guys. Now, nucleophile. This nucleo stands for what? This nucleo stands for nucleus. And phile has come from the term philic. This that no, I'm not talking about that FILE file. This PHILE file means loving. So this nucleophile stands for nucleus loving. What? Nucleus loving. Now, can you tell me what are the species which undergo nucleus nucleophilic substitution, or what makes a particular species act as nucleophile? Let us see that in detail here. Nucleophile. It is very clear that if it is a nucleophile, it must be looking for what? It must be looking for some nucleus or nuclear or positive, positively charged species. And if it is looking for a positively charged species, it means what? That positively charged species must be having lack of electron. Lack of electron. If it is looking for a species which are lack of electron, that is possible only when this particular one is rich in electron. If you have money, you go to mall, you go to shop to spend the money. So the same thing happens to this nucleophile as well. This is rich in money. It simply wants to spend its money. Now here that money stands for electron. Yes, this nucleophile is rich in electron. It wants to spend its electron. Of course, it will go to where those electrons are required. That is, it will go to electrophilic center. Be covering in our next video. So nucleophile. This nucleophile is what? It is nucleophile is nucleus loving. It is electron rich or sufficient species. Now let us see the example. The Cl minus, that is chloride. You can see this chloride, bromide, iodide, all these are having a tendency to donate their lone pair of electron. So these are negatively charged nucleophiles. Note down, guys, negatively charged. These are the different type of nucleophile. So that these are negatively charged nucleophile. Now, if we talk about water, this is neutral nucleophile. You can see the lone pair on water. It is it is neutral nucleophile, guys. Water is a neutral nucleophile. थोड़ा सा पानी बनता है. You also have water. We have this hydroxide, OH minus. We won't call it as hydroxide. Why I raise the term hydroxide? So that I can mention this is not hydroxide, this is a hydroxyl. So what happens here also? This is what? This can be act as a nucleophile. It is a negatively charged nucleophile. Now this is what? Alcohol, this ROH, where due to the lone pair present on this oxygen acts as a nucleophile. This RO minus again, alkoxide is a source act as nucleophile. This RCO can act as nucleophile. This is a H2S nucleus. H2S is neutral molecule acting as nucleophile. HS minus acting as nucleophile. This RSH again due to the lone pair present on sulfur, it acts as a nucleophile, or RS minus same lone due to lone pair it is acting as a nucleophile. So whenever you are supposed to answer that which all the following species are nucleophile, what you're supposed to look for? You're supposed to look for an extra lone pair of electron, or a lone pair of electron which can be easily donated by that particular species. Okay, guys. Or you also can look for the empty d orbital if the species is having. Okay, guys, because of that, like they are what? Nucleophiles. What we have to see? We have to see either for the lone pair or for the extra orbital filled with electron. So a nucleophile, in order to In order for a species to act as nucleophile, it should have lone pair of electron, either as a charge or it should have a filled orbital. It will act as a nucleophile. So a nucleophile can be negatively charged or this guys, they're negatively charged or neutral one. Okay, so they have a tendency to donate their lone pair of electron and get attached to a electrophilic site. So basically, they are what? Yes, coming to the definition. A nucleophile is a chemical species that donates an electron pair to form a chemical bond in relation to a reaction. All molecules or ion with a free pair of electron or at least one pi bond can act as a nucleophile. Remember, you have to look for pi bond as well. Because nucleophiles donate electron, they are also defined as Lewis base. You know what Lewis base are there? Yes, they are the species which have a tendency to donate one pair of electron, guys. Okay, Lewis base. Nucleophile are also what? Basically, they are what? Lewis base. Now, guys, let's just see this, the very important one, vinyl halide. Do not undergo substitution reaction. Why? What is actually the reason behind this? Do not undergo substitution. The substitution means what? A particular group is substituted by another group. Okay, we have seen that nucleophilic substitution means nucleophile will be attacking two vinyl halide where this particular atom should be replaced by what? Should be replaced by a nucleophile, guys. Should be replaced by a nucleophile. In that case, this particular bond should be easily broken down. But what is happening in the case of vinyl halide? You know, see, you can see that there is a double bond which is in alternation with the lone pair present here. Means these two are in the conjugation. Okay, so what will happen here? This pi bond will be shifted to this carbon, and in that case, the lone pair are going to shift here. So after the shifting, we get what? We get species like this where there is a negative charge supposed to be here and positive here. And can you see that here the bond was single, but after conjugation, this bond is no more single. In fact, there is a double bond here. And that is this due to this conjugation, the bond between C and Cl is becoming more stronger, right, guys? You know that bond dissociation energy of a single bond is much less than that of the double bond. So here it has more strengthened, guys. Now you need to supply more energy here in order to break the bond. In order to break this particular bond, you need to supply more energy. So that is not possible here. And therefore, for this, there is no substitution reaction. Because in order to substitute, this nucleophile has to remove this Cl. This nucleophile has to take its position. But in that case, this Cl should come out easily, which is not at all possible because of the partial double bond over here, which is much stronger than the single one. Okay, guys. Now coming to allyl halide. So, what is the allyl halide? See, we have seen what vinyl halide are. Okay. Now we have to see allyl halide. First of all, see the definition of allylic halide. What you have to see that you have to look for the hybridization of the carbon to which halogen is attached. You can see that this carbon is sp3, which is next to sp2 carbon. Such arrangement is called as allylic halide. Okay, guys, that is halogen attached to a carbon which is sp3, but that should be next to an sp2 carbon. Okay, so you can see that this is what allylic halide. Now it is possible that the particular carbon, that particular sp3 carbon, it can be 1 degree, it can be 2 degree. You can see in this case This particular carbon is 2 degree. Here in this case, this X is attached to the carbon, which is 3 degree, guys. Okay. So it may be possible that the halogen attached to sp3 carbon may be 1 degree, maybe 2 degree, or 3 degree. Why I'm telling you all this? Because question have been asked from this as well, that identify the type of carbon atom to which the particular halogen is attached to, or count the total number of 1 degree carbon to which halogen is attached, or 2 degree carbon, or 3 degree carbon. Okay, guys. So you have to be very careful. Don't forget to note down. Now let me test you. See, this is a question which has been asked in NEET. Identify a lilac and lilac group present in the given compound. So you can see the X attached. They all are encircled here. Yes, think for this. What type of this light? This is there. What is the type of this one? What is the type of this one? Okay, guys, any response, any reply? Just try, all of you. Very good, Adarsh. Okay, Adarsh, let me check sound. Am I audible now? Yeah. Oh, okay, Adarsh. Now the sound problem is sorted. Let me check this problem. Am I audible now? Am I audible now? Yes, guys. Am I audible? Am I audible? Please can message in the comment box. Am I audible now? Very good, Sora. Thanks for telling that I am audible now. I hope, guys, all of you guys keep noting down the things, whatever is being taught here. Okay, guys, see, everything is being covered right from the basics. So you'll be getting full benefit over here. But only when you will be taking your pen and copy with you, you will go on jotting down the things, then only it is going to help you. If you have not shared to your friends, please, you are requested to share so that they should also get benefited out of it. And if you are new to the channel, don't forget to subscribe. I hope by this time the question must have been done by you, but I don't find any answer from anyone. Dora, Adarsh, no answer. Subhash, no answer now. Yes, who is this? The supreme leader. Yes, no answer, dear. VK, no answer. Senthil, no answer yet. Dinesh, guys, it will you will be benefited only when you will, this is actually the purpose of live class, where you get interacted to the educator. You are supposed to solve the particular question there itself, then only you will be benefited completely out of the live class. Otherwise, let me tell you, it won't be able to help you all 100%. And always remember, most of you must be thinking, they're simply sitting here, there's no problem, and I'm so happy that you all are at least attending the class. But I tell you, it will be benefited. Others, Sora, it will be benefited only. Central, VK, it will be benefited only when you write down the things. Go on writing the things. You go on replying the questions being asked on the screen. Then only, Sora, then only it will be helped. Because remember, guys, if you are sitting here, you are giving your most valuable thing. You know what? Yes, time. Don't forget that. And these live classes will able to benefit you only when you are, completely interactive with the particular class. The terms interaction, I means, if you are watching it properly with full concentration without missing even a single point. Secondly, if you are going on jotting down the important things being taught over there on the screen. Third, if you're not talking to your friends, simply chit chatting. Fourth, if you are go on solving the question being asked on the screen, then only you are going to get benefit out of it, guys. Otherwise, your valuable thing is getting in vain. Trust me. I won't talk, kind of a buttery talk that, okay, yes, guys, you are doing very well, this or that. I'll be talking only when I'll be, saying all these things. Yes, I do will say, but only when I'll find the answers for this in the comment box, which I don't find like others. Sora, solve it now. This much time should not be taken by you. DK, Senthil, Dinesh. Okay, that's great. Now let us see the answers one by one. See, this particular X is attached to what? Let me change the color of the pen here first of all. Okay, it's not having the option for anything else, then we'll have to, work out with on this one as only. Now, can you see this X attached to the carbon? Can you identify the type of carbon? This one. Yes, it is. It is sp, and this particular one is S. Very good. Very good. Now you all are answering one by one. That's great. Now let me check whether you are correct or not. And what about this one? Again, this is sp3. And this one is also sp3. And all these sp3 carbons are next to what? This is also what? sp2. All these sp3 are attached to sp2 carbon. Therefore, all these three are allylic halide. What these are? These are allylic halide. And as these two X are attached to sp2 carbon, guys, therefore these are vinylic group. Guys, now see 1 degree, 2 degree, and 3 degree. One more thing, this allylic group are further divided as 1 degree, 2 degree, and 3 degree. No doubt, you have to look for the carbon which is attached to how many carbon further. In this case, no doubt this is what? This is allylic. This particular one is allylic halide. But this is a 1 degree halide as this particular carbon is attached to only one carbon here. Now, this particular halide, allylic halide is 2 degree because such questions are have been asked so far in NEET, guys. That is the reason I'm covering it in so much detail. So this halide is attached to 2 degree. So this allylic group is 2 degree allylic group, guys. Okay. Now this one is attached to 3 degree because this particular carbon, can you see the carbon is attached to, this is CS3 group, and this is one carbon, this is another carbon. So this particular carbon is attached to 3 carbon atom, therefore this is 3 degree. And the whole is particularly what? 3 degree allylic carbon. Can be asked the total number of 1 degree allylic carbon, 2 degree allylic carbon, or 3 degree. So these are the questions, these are the two type of questions which have been asked so far in NEET. First of all, you have to identify whether it is allylic or vinylic, and second, you have to count the number of 1 degree, 2 degree, or 3 degree allylic. Now, coming to the question whether allylic halide undergoes substitution reaction or not. See, we have seen that due to conjugation, due to resonance, vinyl halide do not undergo substitution. But let us see whether this allylic halide undergoes substitution reaction or not. First of all, let us see the structure. This particular one represents what? Allylic. Now, what happens? First of all, the nucleophile does what? So, in the presence of the reagent, this X goes away from here and creating a positive charge here. Now you can see that this positive charge is in alternate position to the pi bond. So what type of resonance you are going to see here? Yes, pi bond and positive charge. This becomes as a leaving group. This gets freed as a leaving group, guys. Now let us see whether do they have resonance with them or not. Now just see here. You can see that this positive charge is in very well in resonance with this pi bond. And because of that, what happens? These are shifted here like this. And due to that, we get a positive charge on this particular carbon. In fact, both of the structures we are getting identical like this. That is actually responsible for what? For the resonance. Okay. So these two are the resonating structure we are getting for pi and positive charge resonance. So here, because of that, there is a partial positive charge developed on all the carbon here, guys, like this. And therefore, it creates a very better electrophilic site to which any nucleophile come and easily attack, right? So you have seen that easily the Cl is being replaced by the nucleophile in this case, because always remember, guys, that this X will be substituted only when the particular compound becomes stable after getting detached to that particular group. Always remember, guys. Okay. Sora, am I audible now? Great. Very good. So, what happens? See, if you are giving anything to anyone, you cannot give it at the cost of your interest. You'll be giving only at the cost of your comfortable one. See, because one thing is sometime it may happen that you don't want to after getting detached, after leaving that, you might not be stable, you might not be feeling better. So in order to give a particular thing, in order to get detached by a particular group, the particular compound has to be stable. And here this positive charge is being stable by the resonance. Therefore, this due to the stable intermediate formation, a lilac halide undergo substitution reaction. They get this halogen is easily substituted by a nucleophile. Okay, guys. Now, naming on the basis of hybridization of carbon atom, let us see, we were doing the third category under that. That is aryl halide. We have seen vinyl halide, where the halogen was added to a sp2 carbon atom. We have seen allyl halide, where the halogen was added to sp3 carbon atom, which is next to sp2. And here we are seeing aryl halide, where X is attached to aromatic ring like this. Okay, aryl ring like this. So you can see that here this X is attached like one again monoaryl derivative can be there, diaryl derivative can be there. Can you see what is this structure is? Yes, this is naphthalene. So here you can see that monohalo derivative is there at which position? Yes, this is alpha position. So this is alpha naphthyl group. And here this position is what? This halogen is added to beta. So this is what? Beta naphthyl group, guys. Now again this halogen can be added either to this position or this position or this one or this one. All of them are actually alpha position. No matter where the halogen out of these four is present, it will be called as alpha naphthyl. Okay, derivative only. Now here you can see that this particular one is beta position. Here again three more beta position you'll find here. So this halogen can be present any one of this. Okay, so this will be called as beta naphthyl derivative. Now, guys, aryl halide do not undergo substitution reaction. This is very, very important, guys. This is very, very important and very basic of organic. So please pay full attention here. Okay, Amar, take your very good afternoon, Amar. Okay, take your copy and pen. Happy to see you joining. So if you have missed whatever you have missed, no problem for that. You can see the video offline as well, what you have missed so far. But now be attentive with your copy and pen. And if many not shared to your friends, we share them now so that they also can be benefited. Okay, guys. And if you are new to the channel, don't forget to subscribe here. So why aryl halide? Aryl halide, like vinyl, they do not undergo substitution reaction. So let us see how. See, you have seen that in case of vinyl halide, the X was not able to be removed from that because of the partial double bond. Because of the partial double bond, guys. Because of the partial double bond. So here also something happens like that only. Yes, yes, if you have not shared it to your friends, you are supposed to share it. Okay. And if you like the video, don't forget to like. If you're new to the video, don't forget to subscribe, guys. Amar, take your pen and copy. Sora, yes, all of you now, you have to answer. I am going to ask question very soon. You are supposed to answer them now. Aril Halide, do not undergo substitution. Same thing is happening here as well. See this X, in order to undergo substitution, after losing the X, the structure has to be stable. Or the X, the lone pair of X should not be in resonance with that, or there should not be a partial double bond. So all these things we have seen so far in which case? Yes, in vinyl case. Here also what is happening? You can see that these lone pair are in alternate position to these pi bonds. So what is happening? They are in resonance, they are in conjugation with each other. And due to this, what is happening? There is a partial double bond is developing here between the ring and X. Okay, guys, there is a partial double bond. Okay, there is a partial double bond. That means the X is getting after. See what is happening? This X is getting more tightly attached to the ring by double bond. So the bond dissociation energy is further increasing, which is difficult to be provided over there. So it's difficult to break down here. Okay, guys. So what you are supposed to see, all these are the resonating structure. You can see the resonating structure. I need not to tell, but I will tell because I think most of you have not. I promised you in the beginning that even if you are not practiced or not done the juicy part in 11th, I'm going to help you here. So let us do that. So what happened due to the conjugation? This lone pair, one of the lone pair present on X is in get involved in conjugation like this. The pi bond is shifting this way. You know all these arrow here, guys. So because of that, what is happening? There is a positive charge developed on halogen. Then here there is a double bond formation as all, and here as a pi bond are shifted to this carbon, there must be a negative charge developed on this particular carbon. Now let us see that this negative charge is in further resonance with the adjacent pi bond like this. So this will be shifted to this bond, and that will happen only when this pi bond is shifted to this particular carbon. Because of that, we are getting a negative charge over here. We are getting a positive charge developed here. Now again, this particular one is in resonance with this pi bond, and again it is shifted like this. This will come on this carbon. Eventually we'll be getting a negative charge over here and a pi bond here. So what is happening in total? There is a positive charge on this. Secondly, that is not the issue. Actually, the issue is there is a double bond over here, because of which this halogen gets more tightly attached to the ring. So it is difficult for the nucleophile to replace this. And that is the reason aryl halide do not undergo substitution reaction. Guys, so you have seen so far whether it is vinyl or allyl group, they do not undergo substitution reaction. But if it is an allyl group, it will undergo substitution reaction. Allyl group will undergo substitution reaction. Now, this is very confusing at the time of solving the question. So I would like my very best to, avoid all those doubt by giving a punch click of mine. So if this punch click, if you remember this punch click, this is going to attack your brain with a punch, and it will make you able to recall this, that out of aryl, out of vinyl and aryl, which will undergo substitution. See, out of the three, what will happen? This aryl and vinyl halide will not undergo substitution, right? So how to recall this? Aryl stands for A stands for aryl here, and at the same time A stands for audio. Then V stands for vinyl. At the same time, V stands for video. तो ऑडियो को सुनना होता है, वीडियो को देख. तो दिस अराइल एंड विनाइल हेलाइड क्या करते हैं, इनको ना दिखता है ना सुन। तो ऑडियो विजुअल, ऑडियो वीडियो पंच क्लिक फॉर अराइल एंड विनाइल हेलाइड, आप ऐसे देख सकते हो क्योंकि बिकॉज द हेलोजन इज इन tightly attached by because of the resonance, because of the double bond. If a nucleophile is coming to that, they neither look at that, neither hear from the nucleophile. That is, they do not undergo nucleophilic substitution reaction. They do not undergo substitution reaction. I hope it is clear. They neither see the nucleophile, they nor hear the nucleophile. So aryl and vinyl halide do not undergo substitution reaction. A for audio and V for video. Okay, guys. Krish, note down the things. Yes, learning space is saying that this channel is getting messed up because of no particular schedule here. A bunch of people teaching anything, anytime. No, guys, it is not at all there. Don't use the words what others are saying. First of all, I would say, see, there is a proper schedule, and that schedule will be like you'll be getting access to those schedule only when you subscribe the channel. So I would suggest that rather than going into this, that you should subscribe the NEET UG in English channel first of all. There you will be notified with all the forthcoming videos, forthcoming classes, quiz, everything, time to time. And if you see my previous video, it was lecture 1 on haloalkane. This is lecture 2 on haloalkane. And if you merge both the lectures, if you see the lectures one by one, you'll find that there's not a single thing being missed over here. And the same thing is happening in all other programs, whether it is physics, whether it is biology, botany, zoology, I mean, or now it is like I'm talking about already for chemistry. So these things are not happening, right? So learning space, this is your name, so I'm telling like this, learning space. So this thing are not there, dear. Okay, please subscribe the channel in order to avoid all these confusion. Okay, now, so again, let's repeat the trick, punch click trick for audio, video, that is aryl and vinyl halide do not undergo substitution reaction. A for aryl, A for audio, V for vinyl, V for video. ना दिखता है ना सुनता है किसको, अराइल और विनाइल हेलाइड को न्यूक्लियोफाइल ना दिखता है ना सुनता है, यानी दे डू नॉट रिएक्ट टू द न्यूक्लियोफाइल एट ऑल, ना दिखता है ना सुनता है। ऑडियो वीडियो, ओके, नो ऑडियो नो वीडियो, ना दिखता है ना सुनता है, ओके। So no substitution reaction for aryl and vinyl halide, guys. Now, now let us see the fourth part of that, that is benzyl halide. Can you see toluene here? See, we have seen vinyl, we have seen allyl, we have seen aryl. Now, benzyl. So, what is it, guys? Can anybody answer me in the comment box? What this compound is famous for? What it is called? Very good. Very good, Kirti. Note down the, copy. Note down the things. Take your pen and copy. Can you tell me what is this compound is? Yes, this is very good. This is toluene. Purposely, I have drawn these these three hydrogen like this. So this is toluene. And after the same way as you remove a hydrogen from alkane and you form alkyl, the same way if you remove one hydrogen out of these three, you get benzyl. What you get, guys? Benzyl. See, one hydrogen is removed, then this comes out to be CH2, to which something can be attached. There is a bond free over here. So such group, such structure is called as. And if it is like possible, like one more hydrogen is removed, what will happen? Yes, we'll get formation of benzyl. So two hydrogen are removed. We are forming what? We are getting benzyl. Now, if one more hydrogen is replaced, we are getting benzo. What we are getting, guys? We are getting so. So you have to remember that halogen atom can be attached to this particular bond. If it is attached here, it is benzyl halide. If it is attached here, It is benzyl halide. If it is attached here, it is benzo halide. Hope it is clear. Benzyl, benzyl, benzo. benzo जो जो मतलब क्या? एक लैंग्वेज है हमारे इंडिया में, जो बिहार में, जो मतलब जाओ, जो जाओ, यानी सब जाओ, सारे हाइड्रोजन जाओ। वेयर? इन केस ऑफ बेंजो, जो मतलब जाओ। So this is again a punch click, guys. Benzo. How will you recall what benzo group is? जो, सारे हाइड्रोजन जो, जो मतलब जाओ, तो सब जाओ, सारे हाइड्रोजन। So this is benzo. And how will you recall what benzyl is? Toluene. One hydrogen removed from toluene will give you benzyl. And one more hydrogen removed from benzyl will give you benzyl. And if all hydrogen are gone, sare chale gaye, sab jao, will be what? Benzo. Harsh, just take your copy and pen, because I think you are a good student of Ignite batch, and Ignite batch don't pass their time like this. Ignite batch keep jotting down the things. Ignite, that ignition to study, that ignition to the dream to achieve need, to clear need, is always igniting in a heart. Okay, so behave like that and take your pen and copy, note down the things, and please go on answering the things which is being asked in my, next slide. Be ready for that. So benzylic halide undergo substitution reaction. Yes, you had seen vinyl aryl do not undergo substitution reaction. Allyl undergo. Here the next one is benzylic halide. This benzylic halide undergoes substitution reaction. Let us see how. See, you can see this benzylic halide. See, what you have to see whether a particular species will undergo substitution reaction or not. You have to see that after removing that particular group, the leftover structure is stable or not. This is the basic of history to check the stability. Okay, guys, that is after losing that particular group, the leftover group. See, this group, after losing Cl, there will be a positive charge created on this carbon, and you have to see whether that positive charge is further stabilized by resonance or not. If it is getting stabilized by resonance, that means it will undergo substitution reaction, otherwise not. Okay, so what happens, that positive charge is in conjugation with this pi bond, you can see here. And so because of the resonance, you can see all the resonating structure. We have already explained what how the resonance takes place here. You can see that that particular plus charge is further stabilized by all these resonant structure. That means after losing the Cl, this carbocation is very well stabilized by resonance. Therefore, benzylic halide will undergo substitution reaction. Harsh, take your pen and everything. Very good. Note down the things and be ready for my next video. Okay, so I hope whatever is taught so far you must have must have, I won't say enjoyed, because there's nothing to enjoy. You must have enjoyed the study here. So I would say that you must have enjoyed the studies, because why did I say the use the term enjoy? Because I can see many of you are chit chatting, and because of that only the live classes are badly. Okay, so I would request you all students, don't do that. This is not a point to chit chat with your friends first of all, because by doing that you won't be able to get full benefit out of what is being taught so far in the live classes. Okay, many of you I can see that are studying very well, responding very well in the message box. That's very inspiring, that's very good. But some of you are not doing. Don't do that, guys, because your parents must be observing. You must be thinking that yes, mera bachcha to pad raha hai. Okay, but what happens? The- you are simply not bluffing yourself. At the same time you are bluffing to your parents as well. Don't do that. And most very important thing is, you know what, you are killing your most important life, and that is your. Okay, guys, I would repeat it. Your most valuable thing is what? Your most valuable thing is your time. Don't kill your time. See, I agree that most of you are watching the live classes, most of you are enjoying the live classes, most of you are getting full benefit out of it as well. But I'm concerned to those few as well who are simply coming here to chit chat with their friends, to get updated with their friends, or to get updated what is being taught in the class only. Don't do that. This will simply kill your most valuable thing, and that is time. Okay, so take your pen and copy with you. Keep noting down everything what is being taught. Try to participate in the question being asked so far. Try to participate in the like mechanism or in the writing part, actively writing part. What why I'm saying this? Some of you might take the screenshot. Some of you might think that okay, I'll see the video next time. That will never help. What will help you always, what if you are watching the video at the same time you are getting down the thing, because it is organic chemistry, and organic compounds are highly volatile in nature. I hope you know the meaning of volatile, and if you don't know the meaning of volatile, it's my foremost responsibility to tell you about that. Volatile compounds are what they get evolved very easily. That is, their boiling point are very less. So if you won't note down the things properly, what will happen? These things will get evaporated very. The moment they are coming down into your brain, the very next moment they are evaporating out of your brain as well. What you should do while watching the video, you should note down the things. While a particular question is asked on the screen, you should actively participate in answering the question. Very good. Hello, Sahil. You have joined now. No worries. You can see the offline video, recorded video. No problem. So, okay, guys, I hope I'm very much clear. So, you need not to bluff your friends. Someone is asking, ma'am, how to score better. So, I would suggest you the very first thing to score better is to score yourself in the terms of how the way you are studying, give marks, and how the way you are going to evaluate yourself for the same. See, you have to see whether you are hearing every single word of that or not. First of all, you should check yourself whether you are getting attracted to your friends or not. I mean, attracted in what way? You're involved in chit chatting to your friends or not. No need to answer your friends here. This is not the platform. Okay, second thing, take down your copy and pen. Take down, note down each and everything being taught on the screen. Answer those things. Okay, then only it will be benefit. Okay, guys, so I hope it is very much clear to you that what you are supposed to do, how you can score better. So only the thing is not to, I won't say only study, keep study. You have to check yourself what you're doing also to score better. How you are studying. Okay, not only studying, how you are studying. I hope I'm very much clear for that. Okay, so don't forget to subscribe the video. Let's crack NEET UG in English channel. Don't forget to subscribe the channel in order to have notification for all the forthcoming videos of all the subject, guys. Okay, thank you so much, guys. If you like the video, don't forget to like. And if you really like the video, don't forget to share so that all your friends who could not join us live, they can see the recorded video as well. And for in order to subscribe, in order to take the subscription at the discount price, what you should do, you should refer my referral code. You should use my referral code, and that is SA10. Then only you will able to get all the 10% discount which is you are prescribed. Thank you so much, guys. Okay, till then,